Okay, so let's go a little bit further with our ideas of finding trig functions in all four quadrants. So as you did your delta math, you may have started to recognize that there's kind of a pattern to what's positive and what's negative when. And it has to do with what quadrant you're in, because what quadrant you're in determines if your x and y are positive. For example, in quadrant 1, if you were to draw a triangle in here, you would know that your x and your y are both positive. That means that in quadrant 1, all your trig functions are positive. Sine, cosine, cotangent, all of them. So all are positive in quadrant 1. In quadrant 2, you have a negative x but a positive y. So that means that only sine and cosine, not sine and cosine, only sine and cosecant are positive because they're the only ones that use the positive y coordinate and the positive hypotenuse. In quadrant 3, it is only tangent and cotangent that are positive because in this quadrant, both x and y are negative. So when you put them together in a tangent ratio, the two negatives cancel out and make that positive. And finally, in your fourth quadrant, only your y-coordinate is negative, so only your cosine and your secant are positive because they're the ones that use the x-coordinate. So in quadrant 1, all are positive. In quadrant 2, only sine and cosecant. In quadrant 3, only tangent and cotangent. And in quadrant 4, only cosine and secant. Some people, and I was taught this too, use the phrase all students take calculus to remember A for all, S for sine, T for tangent, and C for cosine. Now you have to remember that cosecant goes with sine and cotangent goes with tangent and cosine goes with secant. But I also think if you just kind of remember about why this is, that sine's positive when the y value is positive, cosine's positive if the x value is positive, tangent's positive if they're both negative, or both positive in the case of quadrant 1. All right, so for example, problem 3, if cosine is positive, so greater than 0, that means it's positive. If cosine is positive, which quadrants could the terminal side of theta lie in? Well, for cosine to be positive, we have to either be in quadrant 1, because everything's positive there, or in quadrant 4, because cosine's also positive there. So if tangent is negative, which quadrants could we be in? Well, tangent is positive in 1 and 3, so we could be anywhere else. We could be in 2 or we could be in 4. If secant is negative, which quadrants could we be in? Well, secant is positive in 1 and 4, so we'd have to be in either 2 or 3. Now, if sine is negative and cotangent's positive, which quadrants could the terminal side of theta lie in? Okay, well, for sine to be negative, sometimes you have to do with process elimination if it's easier to see it this way. For sine to be negative, we know that we cannot be in this quadrant or that quadrant. So now we know cotangent's positive, so we look at our two remaining quadrants, and that only happens in quadrant 3. So we must be in quadrant 3. And it's that fourth question there. I guess it's actually the 6th question. I don't know what happened. I guess 1 and 2 are on the other note sheet. It's that last question there that is going to be really helpful as we work the rest of these problems. So we're going to use one trig function to find all the rest of them. Now we kind of did these before, but only in the first quadrant. So, all right, so the first step with these is to figure out which quadrant you're in. So from here, I have sine. So I know sine is 8/17, so sine must be positive. So let's see, if sine is positive, I'm not down here and I'm not down here. Now I know tangent is negative. Well, for tangent to be negative, I can't be in the first quadrant because everything's positive there. So I must be in the second quadrant. So, oh, looks like tic-tac-toe kind of. So I'm going to sketch in my angle, but I'm going to pay attention to what quadrant I'm in. So for sine to be 8, so here's my little triangle in the quadrant there. So sine is opposite over hypotenuse. And from there, I'm going to use some Pythagorean theorem to find my x value. So I will say, well, then that is going to be x squared plus 8 squared equals 17 squared to find that my b is 15. And then I can but I'm going to remind myself that because I am in the second quadrant, that x value is actually negative. So there's my triangle with a negative 15. So cosine negative 15 over 8. I'm just reading off my triangle because your theta is right here. Tangent, negative 8/15. Cosecant then, 17/8. Secant, negative 17/15. And cotangent, negative 15/8. Okay, so that's that one. Next one. We are given that cotangent is negative 4 and secant is positive. So so let's figure out where we're at. So we know that cotangent is negative. So we cannot be here because that's where cotangent's positive, and we definitely can't be in the first quadrant because everything's positive there. All right, so we're down to either quadrant 2 or quadrant 4. But we're given that secant is positive, and that only happens in the fourth quadrant. So I'm going to sketch in my triangle here using the x-axis as one side and my theta right there. Okay, so it looks like at first we only have a negative 4, but remember that's negative 4 over 1. And cotangent is supposed to be, your reciprocal of tangent. So that's your adjacent over your opposite. So I'm going to write my 4 and 1, and I'm going to put the negative on the 1. Because remember, with a negative fraction, you can put the negative either place. And we got to remember that going out there, if you're going to the right, your 4 should be positive, but going downward, the 1 should be negative. Okay, so Pythagorean theorem. So 1 squared plus 4 squared equals c squared. Maybe I'll use it as an r. So radical 17 is your r right here. And we're going to start writing some ratios. So sine negative 1 over root 17 rationalized to negative root 17 over 17. Cosine 4 over root 17 rationalized to 4 root 17 over 17. Tangent negative 1/4. Cotangent root 17 over 1 or root 17. And secant then is root 17 over 4. And it's a good idea to check yourself at the end with those ratios because you know that you're in the fourth quadrant. So your cosine and your secant should be positive, but everything else should be negative. So in fact, as I'm checking myself here, I say, okay, sine negative, that's good. Cosine positive, that's good. Tangent negative, that's good. Oh, cosecant should be negative. I must have left that off. So because I forgot that it was radical 17 over negative 1. So I caught myself there by checking that the right things were positive or negative in the right place. In fact, I should probably go back and check number 7. So for number 7 in that second quadrant, cosine negative, tangent negative, cosecant positive, secant negative, cotangent negative. Okay, I got all that.